Hello guys. In this video we will see how to create scripted components. Scripted components are somehow similar to microcontrollers. But instead of executing code stored in the program memory, it executes in script. Let's see an scripted component included in the default installation. This is a digital to analog converter. Let's have a look to the files. An scripted component is defined in 3 files: script file, package file, and MCU file. The package file defines the graphical representation of the component. Note that the IDs of the pins are used in the rest of the files. So let's create a new scripted component from scratch. To make it easy, we will use a special folder to add our files. Go to your user data folder and create a folder with name test. Inside that folder we create the folder for our component, a voltage amplifier. The name of this folder will be the name of our component, and we will use it for the other files as well. We can find our folders in the file browser. In the bookmark, user data. Let's start by creating our package file. For that we will use the package component. First, let's configure the package size. I think 4x4 is okay. Now let's create 2 pins, one for the input and one for the output. To create a pin, press the Shift key and place the mouse cursor where you want the pin. When you are ready, click, and the configuration dialog will open. The pin name is what is shown in the screen, and the pin ID is its unique identifier. In most cases you will use the same for both. Let's do the same for the output pin. And that's all, our package is ready. Let's save it to get our package file. We go to the folder we created previously. And save it with the same name we used for the folder. And there it is. Now let's create the MCU file. First we create an empty file with the same name used before. And extension, MCU. And we open it in the editor. I will copy-paste the content from dac.mcu. And modify what I need. Name. Script file name. And pins. Note that pins are created inside ports. In this case we will use only one port with 2 pins, using the same identifiers in the package. Note that these names are case sensitive. We save our file. And now is time for our script file. We need to create a file with the same name and extension as and open it in the editor. Now we have all the files we need. So let's close the application and open it again. If we scroll down the component list, we will see a new category, Test, with our component, Amplifier. Now we can bring it to the circuit and start working in the script. We get an error because the script is still empty. So let's open our script file to define what it should do. Following my rule of being as lazy as possible, I will copy-paste a similar script and edit it. I think that is all. In our reset function we configure input pin as input, output pin as output, and output voltage to 0. Then we read the input voltage, multiply by 2, and set the output voltage. Let's save this file. Now let's compile it. Nice, seems that it's correct. So let's see if the component actually works. We can use a voltage source connected to the input and a probe to the output. And run the circuit. Well, it doesn't work. Seems that we didn't upload the script to the component. Now it should work. What? Oh, I see. There is something missing. Let's copy-paste it from another script. Here it is. We need to set the output voltage every time the input changes. For that we use this function. We tell the input pin to call us every time it detects a voltage change. Then it will call this function. Let's compile and upload. Seems that we made some error. Error at line 24? Oh yes, of course, I deleted a bracket. Now, another error. Error at line 20. Oh yes, input pin should start with lowercase. Anything else? Nice. Compiled and uploaded. But, will it work? Yes! Our amazing voltage doubler is finished. In the next video we will add more features to this component. So stay tuned, subscribe, like, etc.